But quiz 1 was basically, again, I can't review the solutions. Do you have a question about the last?
Yeah, so I plugged all that in and I did the E and E and they both work.
Does E work?
Yeah.
Okay. So I'll put both of those as solutions. So MATLAB changes syntax all the time. So I have to constantly update it. So if you put either of those, that's okay. Thanks for letting me know. So just in general with the dot, you can almost always use it, even when it's incorrect to use it, or not necessary to use it. It didn't used to be for the plus and minus, but anyway. Now, for the quiz. So everyone is always taking a different quiz, so I won't be able to go over quiz solutions in lecture, but I will try to go over some important concepts that were in the quiz. So, for example, one of the things you did in the quiz is the input function. And on the lab, there's a bonus question that asks you to kind of figure out how character strings work for input functions and for display functions. So that was the new thing on the quiz. The quiz will always have, as sort of like to get an A on the quiz, you kind of using a function in a new way that you haven't used before. So in the quiz, this was to be able to prompt a string. Now there's two ways. The first way I have up there is that the user enters in the string with string quotes around it. And then it will work fine. So if you didn't do that and you tried to just put in Shannon without strings around it, it wouldn't work. The second way is you can add a second input to the function input, which is S, and then you don't have to put the name in strings. So those are the two ways. So hopefully you figured out one of those two ways, or you got kind of close. There's also, okay, I didn't finish the slide. I will have to update this. So there's two ways to display a string. One is with the display command and one is with fprintf. So you could have used either. I'll update this and post it so you can see the fprintf syntax, but actually most people have been using fprintf and hopefully that's more familiar. And I also showed this in last lecture as well. So those were the two things that I just wanted to review for the quiz. Let's just talk a little bit about what you should have learned for topic 2. And again, I'm going to encourage you to go to that first page of your MATLAB binder packet that you picked up. Just review all the concepts, every topic after we finish a topic, and make sure that that's all familiar to you. Some of the main things that you did is you learned how to create, access, and manipulate arrays. And so there's a lot of different syntax you can use for those types of things. You learned the difference between the asterisk and the dot asterisk, or the division symbol and the dot division symbol, and then the power symbol as well. For accessing, you should be familiar with both single and double index notation. Single index notation is horrible to use in a 2D array, and you should just avoid it, but it does exist. You learned a couple new functions: length, size, ones, zeros, reshape. Also, fprintf and input are also functions that you learned. Wait, that was topic 1, sorry. Then you also learned the find and max function, and some of you are still working on lab 2, so you could still be kind of working through that. I had a tip that I wanted to show you this time because it's a very common mistake that I have seen several times in the lab, which is that an error you'll often see in MATLAB is index exceeds matrix dimensions. And typically what it means is the first example. So you have an array A, goes from 1 to 10, so it's size 10, right? And I'm trying to access the 11th element, which doesn't exist, so it gives you the error, index exceeds matrix dimension. That's a nice error to get because it makes sense, right? And then you're like, oh, I'm trying to access an index that doesn't exist. However, you can get that in many ways. So another example, disp is a function, right? DISP is a function. But let's say I chose to use disp as my variable name, so I overwrote the disp function with 15. Then I wanted to go back and use the disp function, so I did disp hello. It's not going to work, and it's going to give you the exact same error because you're trying to access the hello element of disp, which doesn't exist because that's a string. Does that make sense? So it's a little bit of a confusing error, but the one time you see it most frequently is with over or special variables that already exist in MATLAB. All right, so I have a handout for you today. We're doing plotting, which is very exciting. I almost always do this every other time I've taught the class. I'm just going to break this up a little bit more. Every time I've taught this class, I've presented this topic at topic 7 or 8. So I've moved this up to topic 3. And I did it because we have so many visual learners that I wanted to introduce it earlier. Did you have a question?
Yeah, so you override a function.
Yeah.
When you close MATLAB, this is start fresh again.
Yeah, excellent point. So you override a function. So you either need to clear all your variables to get it back, or if you restart MATLAB, it's going to be back to normal. That's why it's good to clear all the top of your file, but if you're overwriting the function in your file, you'll still have the problem. Yeah. Mm-hmm. Oh, you can just hit clear and then the name of the variable to clear a single variable. Yep. Which is sometimes useful if you don't want to get rid of everything. Another question? Yep. Yeah, that could be. We don't have any issues in the spots where we're running anything where that would be a problem, but that's probably true, yeah. So clear bars is what it's supposed to do? Yeah. Either is fine. Any other questions? Great. Okay, so what I've passed out to you right now is it's just a handout that gives you some syntax so that you can follow my lecture. Because if there's any topic that has more syntax than plotting, there isn't. This has the most. I will never ever be able to teach you what you need to know about plotting. I can only show you the most important things, and you're going to have to figure out a lot of it on your own as you go. So what I've done is I've copied down all of the commands I'm going to use today in lecture, so you don't have to switch to make sure you can read exactly what it says. You can refer to this, and then on the front page I have an outline of what I'm going to cover for 2D plotting, and then on the back I have an outline of what I'm going to cover for 3D plotting. So I'm going to keep the outline up on the left screen, and I'm going to just use MATLAB on the right screen. So I don't have every single command that I'm going to do, I just have the syntax. Now we're going to start with 2D graphics and plots. 2D plots are line plots. That's how I'm defining 2D graphics. Where 3D graphics are surface plots, contour plots, something that has some variable that depends on 2 dimensions. It's a little bit confusing. I did that because I'm following the textbook's notation. So we're going to start, anytime we're plotting, we need to have some data to plot. And so because we haven't learned how to import and export data yet into MATLAB, we're going to always have to create our own data. So what I'm going to do is I'm just going to create an X array, and then I'm just going to define a sign function. So I'm just going to have a Y array that holds the sign of X. So this is the X and Y that I'm going to start with. This is just because I need something to plot. Okay. The reason I type for you while I code is because sometimes it helps to see how someone programs. There's a lot of little tricks that people might use that you just would never see before. So the first thing is to open up a figure in MATLAB. You need to type the word figure. If you don't, it will automatically, but a lot of times you'll be creating multiple figures. And so figure opens up a new one and doesn't overwrite the existing one. So it's kind of good practice to just always open up one when you're starting a plot. Okay. Now, to just do a line plot, the command is plot. That's the function name for plot. And by the minimum inputs to the plot function is that you just need to put in one array. So if I just put in Y, it's going to open up the figure and it's going to plot the sign function. What you'll notice is that my X goes from 0 to 2 pi, but on my plot it goes from 0 to 65. Does anyone have any idea why the x would go from 0 to 65? Yeah.
Is it because you didn't plot X?
It's because I didn't plot at x, and 0 to 65 is actually the element numbers associated with each y. So there happens to be like 65 points in the y array, and so it's just plotting integers on the x-axis. So that's the default if you don't give it an x. If you give it an x, it will plot appropriately the x versus the y, and the x-axis will be correct. So that's a basic plot. There's a lot of customization that you want to do to plots, and you always want to program them into your code because it saves you a lot of time. So let me show you what I mean. So here I have a plot that we just did. I can do almost anything within this GUI. So a GUI is a graphical user interface, so that's what this plot is. And it has all these buttons that you can click on, and you can just mess around by clicking buttons. But for every button that you click, there's a command that you can use. And you want to use the command because then every time you get this plot, you would have to re-push all the buttons. Where if you have the command, it'll just automatically do it. So I can do edit plot, I can click on the line and right click, and I can change it to like a thicker line width or something. You know, you can do all this stuff interactively. But we want to learn how to do all that command line so we don't have to do it like by hand. So for example, you can add labels to the axis. So here is a label. So x label is the function to label the axis. You can also do the same thing with y label. Same function, but it goes on the y. And then you can also give it a title. And all of these things, when they get executed, will just go straight into your plot. Now, on this screen, it's actually really hard to read this text because the default text is pretty small. The other thing I want to show you is that every time I've run the code, a new figure is opened up. So I have all these old figures that keep popping up. That's very irritating because you can't find the one that you're looking at. So just like I told you, you should type clear all at the top of the function. You could also get into the habit of typing close all. It'll close all your existing figures and it will pop open a new figure. So that's a nice thing to always put at the top of every file. So you can also change anything about the X label, Y label, and title. You can change the font, you can change the font size. So for example, I'll just show you the font size. You can add an additional input to the X label, Y label, and title function, and it will increase the size of those labels. And I'm just showing you one thing you can change, but just know that if there's anything you want to change about that text, you can. Okay.
Are those case sensitive?
The function names?
Font size.
No, font size is not case sensitive, but MATLAB is case sensitive in general. The variables and stuff like that are case sensitive, but you don't have to capitalize the F and S, or you can. Again, I learned how to program in MATLAB kind of a long time ago, so I keep a lot of syntax that I use that's old, and they've since made it a lot more flexible. So just old person up here programming. Okay, changing the line width. Let's do that. So if I put the plot function, you can add additional inputs to the plot function to customize the look of the plot. So for example, if I increase the line width to 2, the default is 1, by the way, the one that you're seeing, that will come up with a thicker line, and obviously the bigger the number, the thicker the line will be. Let's see. You could also customize the color and style of the line. So let me show you a couple options. I'm going to show you 2 options for this. Okay, so there's a shorthand in MATLAB, and that's what I use most frequently because I'm never trying to do anything too fancy, but it's a little bit trickier to get used to. So the shorthand is
that you can add the color that you would like the line to change to, and there's a single letter associated with every normal color. So red is R, blue is B, black is K. So if I want to change the line to red, I just put in an R. And then if I want to change the line style, I'm just going to use the shorthand for the line style. So the line style I'm going to use is a dotted line, and that's a colon. So that's the shorthand for changing line style. So now you can see I have a dotted line that's red. Question?
Does it matter what order you put those operations in?
Yes. It has to be color line style. And there's one more shorthand as well. So I'm going to pull up the help and show you some of the options. If there's somewhere in here, we need to go to lines. Oh, just some. Okay. So I just saw the markers. So these are the markers. I'll talk about those in a second. Here's the color shorthand. So here's all the colors. So if you don't have to remember them, you just go to the help. You can see the color table. And then you can also always use the RGB equivalent to the color using the red, green, and blue percentage that you would like. So you don't have to use the standard colors. You can use some percentages. And I saw the line styles, but I must have skipped them. Right here. So here's the line styles. Here's a solid line, a dashed line, a dotted line, and a dot dash line. Okay? That's the one way to do it. So this is the quick kind of shorthand way. Sometimes that doesn't work if you're trying to do something that's a little bit more, like something a little bit more sophisticated that doesn't have a shorthand to it. So the other option is to just call out those things. So you can do color and then put the color that you want in. So red would be R0, or 100 is red. That's the RGB color for red. You could also just type, I think you can also just put in red, but you don't have to use a shorthand. And then for line style, there are only those line styles that I showed you. So those are the only options. There's no, that is the only shorthand, but you can also enter it in by calling out line style and executing the code. So you're going to see the same thing because I just did it the same way with a different option. Any questions about that? Yeah.
On your example here, you have a star next to the R. Only the star.
That's the next thing. So changing the markers. Love that you're looking at that sheet. Okay, so I just say weird things all the time. The first time I taught, I'm not telling you this actually. Turn off that story. Okay. Okay. So how do you do markers? I'm seriously not telling you. Okay. So there's actually 3 codes for the marker style. So it goes, or for the shorthand. So it's marker style, color, line style. Those are the 3 codes. So if I put a star, R, and then a dotted line, it's actually going to mark each point with a star. It's going to color it red, and it's going to connect the points with a dotted line. Now, I have way too many points in here to be able to show that. No, not really, actually. So I'm going to take out the dots and just do the marker and the color. And I'll change the color to blue just so we can look at something other than that. So here, I don't have a line style indicated, so none is assumed. And I've just put a marker of a star. So if you want to do a scatter plot in MATLAB, this is the easiest way to do it. There is a function called scatter, and it works just the same way plot does, but it just defaults to markers only. I wouldn't suggest using it because the syntax for customizing scatter is different, and so it's just a little bit annoying. You can use it if you want, but I think plot is just the most general. Just like there's 2 options, you can also change the marker size with the long, like not the shorthand. So to do the same thing, but not have this little code, you just type marker and then put in the style that you want, and then color. Should be 001. So this will do the same thing. and then you have to change line style to none without the shorthand. So line style, and then none is also a string. Okay, so that's the same thing. You can also change other things about the marker. You could just outline the marker. You could change the fill of the marker. There's a lot of different things. You can change the size of the marker, and those are all only customizable via this long option, option 2. And let me just show you a couple of the other markers. S is square, for example, and it comes defaulted as it's not filled in, but you could also fill in the square. Just basically you can do anything you want with any of these plots. You can change anything. Any questions so far about these plots? Okay, next thing I want to show you is multiple plots. So let's say you want to put multiple lines. Let's say you want to plot multiple lines on the same plot. A couple options here. So the first option is that you can just list the lines right next to each other. So I'm going to first plot X and Y, and I'm going to color it red, and then I'm going to plot X and the 2 times Y, and I'm going to color that black. Okay, so that's the first syntax option for plotting multiple lines on a single plot. So let me show you what that looks like. And I'm going to increase the line width here because it's just hard for you to see in the lecture here. All right, so typically if you plot more than one line on a single figure, you want to know which line is which, right? So the function to label the lines is called legend, and you just put in the names of each line in order of the way that you plotted them. So I'm going to name the first one Y and the second one 2Y, and that will bring up a figure that has not only the lines but also labels the lines with a legend. Again, you can increase the font size of all of this stuff so that you can actually read it, but that's the basics. Okay, that sometimes doesn't work for some of the things that you need to do. So option 2 uses the hold on function. So option 2, you're going to split the plots into 2 lines. So first you plot the first line, and then you type the command hold on. Hold on keeps the line on the plot and plots the next line over it. If you don't have hold on, it will replace the line with the new line. So I haven't opened up any new figures this whole time that I've been typing, and it just keeps replacing my figure, right? It keeps replacing it with the latest thing that I've been showing you. So in order to not have it replace, that's what the hold on command does. For some plotting, the colors get kind of messed up, and it doesn't switch colors automatically, so you can also use the command hold all, which holds more things. So here's the same thing with option 2. So you get the same thing, but it's different syntax. Any questions? Yeah. No, it holds on until you hold off, or open a new figure, or open a new subplot, which is what we're going to talk about now. Any other questions? All right, so I'm going to create some new data because I'm going to show you a log plot, so I need a little bit different data to show you this. You'll notice that when I create arrays, I always open and close my arrays so that I don't ever have to worry about parentheses problems of not having a match. That's just a really common thing that programmers will do, is they open and close parentheses or brackets or whatever. Okay, so here's some data that I'm going to use. What I'm going to do here is I'm going to show you how to use log plots. So one thing you'll notice about this data is it spans several orders of magnitude. So if I try to just plot this data as is, you'll see that I can't see a lot of details of what's happening in the small numbers because the big numbers are blowing up my y-axis. Okay, so a lot of times for this kind of data, we want to use what's called a log plot. So to do a log plot, there's a different function than plot. But what I want to show you before that is something called subplot. Subplot breaks your figure up into subplots so that you can plot different lines in the coordinates. So let me show you what it looks like. So I put in subplot 2, 2, 1. What that means is it's going to split my plot up into 4 quadrants, a 2 by 2, and it's going to plot everything after it into the first quadrant. So you can see that my plot went into this top corner, the first plot. Okay, so to show you a log plot, I'm now going to go into the second quadrant that I created, and I'm basically going to take the log of both x and y, and so now I'm going to have orders of magnitude shown on both x and y. So this changes. This actually only spans 1 order of magnitude, so you see that is just kind of the same on the x-axis, but you can see the y-axis is in orders of 10, and so you can see a lot more information about how the data is spanning. And then if I want to, I'm just going to show you the other 2 ways that you can do log plots. There's just 2 other options. So I'm going to go and copy and paste these other 2 quadrants, so the 3rd and the 4th. This one, I'm going to do something called semilog x. That's going to take the log of only the x-axis. And then semilog y will take the log of only the y-axis. So when I run this, you'll see all 4 options that you have for plotting. This is a regular xy plot. This is a log on both axes. This is a log only on the x, and this is a log only on the y. So if your data spans many orders of magnitude in either x or y, you want to log those axes basically to show it a little bit better. It doesn't change the data, it just shows you how, it just changes how it appears. Okay, I'm going to move on to some 3D plotting, and I'm going to have to show you some of this other syntax in a handout that I'll put on D2L. So in the pre-lab, you'll do some 3D data creation. So I'm just going to move over and copy some of this 3D data over so I don't have to type it. So I can just show you how it works. Explain mesh grid. Okay. Oh, shoot. Is that going to be a problem? Just see, I guess. Okay. Here's my x2. I just want to show you the plotting of this, so I'm just going to grab x2, y2. Okay, so I just need some 3D data. You'll go through some of this in the pre-lab, how to create this data. For now, I'm just going to show you the plotting of 3D data. So there's 2 kinds of plots that we're going to use. So I'm going to split my plot up into 2 again so I can show you both. So I'm going to just do a 2 by 1 now. And so I just have 2 different plots to plot into. The first type of plot I'm going to show you is the contour plot. So contour plot, if you've hiked or used maps, is just going to show you the elevation profile of the data. So you can kind of just think of this as we're looking at elevation data. That would probably be the easiest way to think about it. So let me show you what that looks like. So that's a contour plot. The function is contour f. And then the other type of 3D plot that we use is, whoops, clicked the wrong play, is a surface plot. So this is the same data plotted 2 different ways. The top way is a contour plot, so you're kind of like looking down at a surface plot. And then the second way is a surface plot. So you just have some, think of this as like mountain data with like, I guess a dip or something, I don't know. And so this is the profile where you can actually see the elevation in 3-dimensional space, and this is not. And you can actually use some of these toggling features, and you can see that if you toggle it and just look from above, it looks the same as a contour. There's a ton of customization you can do with these as well. All of the syntax is in the handout, but just a few things. The titles and X labels, those work the same. The other thing that's kind of fun is you can change the coloring that's defaulted. So there's a different color scheme, and they all have codes. So for example, I changed the color map to cool, and it changed the distribution of how the colors were changing. You can also change, guys, 2 more minutes. Cool it. You can handle this. So you can also change the way the axes are. So axes square will square off the axes, and axes tight will cut off anything that's not showing up. And another really convenient one is called shading interp, and this is only for a surface plot, and you'll see that shading interp will get rid of those mesh lines, and it will just shade it. Sometimes looks a little bit nicer depending on your data. So I'm going to actually post an entire handout of most of the stuff I talked plus extra of the commands and what you see in the commands on D2L. So check that out as you're working through your pre-lab. Otherwise, you have a lot of the syntax in the handout that I just gave you. Thank you.